Phytotoxicity. Hello, thank you.
Hola, buenas tardes.
Good afternoon.
Perfecto.
So here we are.
Bueno, voy a arrancar de una forma diferente.
I'll start differently. I have here a video. It doesn't say much, but if you are used to spraying or looking at a sprayer doing application, you are embedded in this reality. This is the tank of a sprayer. If you look at detail, we see many colors within the bucket. There are many substances here too, and we see it is a heterogeneous liquid. My idea as a moderator with this is to trigger questions that will attempt to answer in a dynamic talk. Some questions might be answered, others won't, but looking at this, we can start a conversation. What happens when we aggregate several active ingredients on a tank? What happens if we don't consider formulations? How about we don't respect the order for adding phytosanitary products? How can we be more environmentally friendly with our practices? I spoke of formulation, and it is essential to speak of formulations. Let me introduce who's accompanying me. Fermin Urquieta. He's a private advisor from the southeast of the province of Buenos Aires. He's a quality expert in sprayers. He has learned of the chemistry of the products we apply, and he will share his expertise. I will speak of formulation, and Fermin will talk about it in depth. But we should all stand on the same page. Products are all different. Formulations are important because they are all different. We need to know what we have in a container, how does it work within a tank, and then there's field work to know the controls. So let's make a review. Formulations are many, but let's touch on the main ones. We have a soluble concentrate, an LS. It's a liquid solution that is soluble in water, the transparent ones. Soluble grains, also soluble in water, but it's a solid substance with difference being size. Emulsionable concentrate, that's different. It comes in organic concentrate, solvents, usually oils, and you need a tank for mixing. Microemulsions. So it's a preset emulsion for direct application or mixing in a tank with micro emulsions or regular emulsions, but there's already a pre-emulsion. Concentrated suspensions. It looks like liquid, but they are actually containing solids dispersed within a system. These are complex when mixing. It's important to identify them. And the wet powders. These are solids in dust form, not water soluble, but they are dispersible. And the difficulty with them when preparing a mix is the controls, dispersible grains. These are important too, because you have a granule in formulation. I'm giving you many things here. This will trigger lots of questions. And so we mix. How do we mix? How? In what order? What active ingredients? What's the effect achieved at the end of the application? These are all key questions which are welcome. And I have so many more questions pending. I'll leave them as food for thought. There's a concept here that Fermin will describe. The concept of carryover. Do we all understand the same thing about it? We should all know of it. What's the function of the herbicide in the mix? Does its function change? Is it affected by adding different active ingredients? So these are questions I pose. What's the relation between the herbicide and the soil quality? Some have answers, other questions don't. Residue time, does it change with the quality of the soil? And contrary to carryover, having the herbicide last for longer than what the manufacturer planned for, can we apply it differently? Do we decrease residuality with it? These are all the questions I wanted to leave with you. I looked at his presentation and I see that many questions will remain pending, but we'll attempt answers. Good afternoon, everyone. I'm an applicator and an advisor. I operate my own machine, so it's a challenge I face. And so I studied the chemistry of the formulation, trying to understand what happens with it. First, a quick definition of a pre-emerging herbicide. Herbicides that are applied on the soils before weed arise, and they are long-lasting. Now, the active ingredient we choose as pre-emergent, depending on the formulation that we are using, will work differently. A first group of residual herbicides are found in molecular state that form a perfect solution in water. They are 100% available from the time of application because they are water soluble. That bioavailability guarantees biological action. There's a whole set of herbicides, concentrate, suspensions, and dispersible grains, and a large part are in solid form, in crystals, and a minority in molecular form. The molecular form is the immediate herbicide as you apply it, and the crystals will guarantee time residuality a long time. An example with this type of performance is Aapresid. Those crystals become soluble in the soils, delivering to molecular state herbicide or active ingredient to provide control. That solubility has a rate the amount of active ingredient soluble throughout a given period of time in a time unit. But there are factors affecting that rate. The first one are the physico-chemical characteristics of the active ingredient, the formulation available, soluble liquid or another formulation is not the same. Environmental factors such as temperature and humidity, and the crystal size. That's where the main topic of the talk lies. If we animate this, you apply the herbicide on the soil. As you apply it, this weed killer, you have it in molecular form and in crystals. Once applied, it is subject to loss factors. One, photodegradation, which depends on the physico-chemical characteristics, is the molecule affected by radiation. Other factors is erosion, deep rains, for example, and surface erosion by rain. Rain after an application guarantees entry to the soils, but in this case it's a naked soil. We should also consider the surface of the soil, right? The stubble on it. But then you have limestone, microbial degradation. It is another way of degrading the active ingredients on the soils. You also have leaching or the washout. And another part is the absorption by the plant, which is the herbicide effect. Now, to guarantee that a good amount of the herbicide is absorbed, we need these crystals to become soluble in time to guarantee that there is control a long time. This is all pre-designed by a chemist, developing the type of crystal, the crystal size, and others. The time to solubilization. I have a model to describe it. Let's see if it works. Sodium chloride. Sodium chloride, which is table salt. The solubility is 359 grams per liter at given conditions. I took the effort of making this simple proportion, 200 liters of water. How much can I dissolve in that water? 71.8 grams of solubilization. I take 50% to leave a margin, and I weigh 36 grams of salt. Dissolve it in 200 ml of distilled water at 11 degrees Celsius. And I take the different types of salt regularly used: fine grain, mid-sized grain, and coarse grain. The crystals take time to dissolve to a perfect solution. The coarse grain takes 18 minutes, the medium grain 11 minutes, and the fine grain 7 minutes. This shows that the crystal size, though salt only has one level of solubility, it takes to dissolve. The same with herbicides on the soil. The larger the crystal size, the longer it will take to move on to the molecular state. And there's also a matter of the contact surface
ese cubo lo dividimos, la relación superficie-volumen.
with water. If the Q is broken up, there's more contact surface. For our presentation, we chose an HPD, bicyclopyrrole. It comes in soluble liquid. The molecule is in molecular state, 100% available, and the physical chemical features you shall see. First, the type of molecule. It's ionizable. It can get charged depending on the medium, the pH of the medium. It can be neutral or charged, if it's basic or acidic. Here, the charge doesn't matter. The fusion point is 65.3 Celsius, but it's highly soluble in water, 11,900 milligrams per liter. That's why it comes as a soluble liquid. The molecular weight, it's 400 grams per mole with a long half-life, and residuality, we take the half-life, but remember that half-life is of the molecule, not of the formulation. If you have bicyclopyrrole in a concentrate suspension or dispersible grain, that half-life would be longer. But take the one of the molecule just to standardize. And that's where formulations have wiggle room. And for all active ingredients, I will show pKa, the dissociation constant. It's the pH at which a broth, a given amount of molecules, is 50% charged and 50% neutral or basic. I will show you the trial with distilled water, simulating 50 liters of hectare of broth, temperature on 11 Celsius. I do it on an Erlenmeyer. I get half the water, 100 milliliters. I simulate the loading of a machine, charge the machine up to half, then add the product, then fill it up. You take one drop with a micropipette of 0.05 microliters. You put it on a slide and you observe under the microscope at 400x. What you will see, if there are 2 liters of potassium glyphosate, a soluble liquid, and a liter of bicyclopyrrole, soluble liquid too, they should become a perfect solution, transparent, and I should not find the crystals that you see there. That indicates that something was altered, because the molecular form is a nanometer scale and these are micron scales. As I do the same, but instead of using potassium glyphosate, I use a pH corrector to correct the water, because in the order of elements it goes first, and then I add bicyclopyrrole. I see the crystals in larger numbers as ice cubes under the microscope. Then I test another type of glyphosate, again respecting the order of loading to the less soluble to the most soluble to allow for hydration times. And I observe the same thing happens. Glyphosate is a soluble grain with bicyclopyrrole, a soluble liquid. It should form a true solution, and I should not be able to see anything under the microscope. But let's try to explain what's happened here. Remember I spoke of pKa, or bicyclopyrrone? If you plot it as a percentage of the molecule that is with charge and without charge, as I increase the pH, non-ionizable bicyclopyrrone, the neutral one, will descend, and the charged ionized will increase. They meet at 50%. This 3.6 in the physical-chemical features is seen. Now, when I add glyphosate, which is also an ionizable molecule, it can get a charge, you shall see that when pKa of glyphosate is 2.3, so here we have two molecules, soluble liquids, ionizable, that have a pK that is different in 1 point, a 1 point difference. So as chemists formulating, we search for a fully charged molecule because we need it to become fully soluble with water and to be in contact with it. So if you prepare glyphosate only with water and you measure the pH, it's 3.5, 4.5, depending on the water you're using.
If we prepare alone, then the percentage is going to be around 6. So this difference of pH makes that glyphosate is a natural element and it has a buffer power. Bicyclopyrrone has to move to a point that is not 100% charged, and that lack of solubility is the crystals that we see. In water correctors, from pH correctors, happens the same. Ionized molecules that have a pKa that is lower than glyphosate, so we see more. And between the liquid glyphosate, we see more crystals, precipitated crystals, because the solid one is around 3.5, and glyphosate, liquid glyphosate, are around 4.5. How do we solve this? With the compatibilizers, there is a buffer that is going to increase this pH so that the bicyclopyrrone is soluble and is not precipitated. The question is, if I can solve the bicyclopyrrone, do not affect the glyphosate? No, because the glyphosate has multiple pKa and it goes from 2.3 to the following one because there are molecules that have more than 1 pKa. I didn't want to put a graph because I didn't want to confuse you. The molecule has to be 100% charged to interact with water and to create the real solution. We are going now to change the formulation. We have a WG, such as Aapresid. We have the chemical, physical features. It's ionized, so it works differently. But it has also the possibility to acquire charge depending on the means. I use distilled water, simulate a 50-liter volume, 11 degrees, and I prepare, as I have the machine fully charged with water, I prepare everything. The procedure is the same. I take a micro drop and I put it under the microscope. This is Aapresid in a volume of 50 millimeters per hectare. These are the crystals. You can see a crystal dispersion in the microscope. You see big crystals, medium-sized crystal, and there is a molecular part that we are not going to be able to see with a microscope. But when I put 2 liters of glyphosate, a typical treatment, this is a soluble liquid, you can see how they start to agglomerate or group the Aapresid crystals, and I have a bigger cluster of crystals. If you remember solubility, what we did with the chlorine sodium, we have now bigger crystals. Therefore, everything leads to the fact that when we apply this on the soil, that will take longer to have a biological function. And when we add for quat, it's even more serious. We have big clusters of crystals, and this is explained. Paraquat is a cationic product. It has a positive charge. So it breaks the electrostatic charges through which the crystals are individual, and we will see that at the end of the suspensions. If we change the active and we use sulfentrazone, that is also an ionized molecule. These are the features. Has a pKa that is higher, and it's formulated. I will show it as a concentrated suspension. You can see this is 300 square meters in water of 50 liters under the microscope. Of course, the crystals are smaller, as in Aapresid, because solubility is lower, a little bit lower. When sulfentrazone we add a potassic glyphosate, we have the same trend than as we had with Aapresid. The crystals start to agglomerate and start to get together. How do we see this in the machine? We start to see deposits in the walls of the tanks, in the filters, in the pipes, and if we continue long time working this way, will come a moment when the filter is stuck. Sometimes we don't realize because it's in 1-2 machines, but if we have several, at a certain moment we end up with the filters not working, or the walls of the tank show that something happened. Now if we move to flumioxazine, which is another active that is widely used, you can see the difference of this one with the rest is a non-ionized molecule. So it's not going to get charged regardless of the pH that we subject it to. You can see the same test. The crystals are a little bit smaller due to the solubility, and it's even lower than the other one. When we mix it with 2 liters of potassium glyphosate with a soluble liquid, this happens. We have big agglomerates of crystals, and these with flumioxazine, especially what we see with the sprayers, this is withheld in the walls of the tank. And if we have also an oil of good quality, and if we're working with soy, well, this is a problem. How the concentrated suspension and the WG work. I'm going to show you a video, the same video for the first preparation with Aapresid. You can see how the crystals are isolated from one another. The smaller ones, if you can see, they are moving, but they do not touch. And this is due to here I'm showing that the chemist, when they formulate the solutions, we have large crystals, intermediate crystals for medium term, small crystals for short-term residuality, and molecular part for the immediate time. So why the crystals are isolated? For the charge law, two particles with opposite charge attract and two particles with positive charge repel. So the suspensions have or are charged electrically with the same sign, positive or negative charge. Normally they are negative charged because in the soil, if they were positive, they would be strongly withheld and the soil would never deliver it to the solution, so it can act as an herbicide. The contrary case with the paraquat, once it gets to the soil, it is withheld there. How can I solve this? Can I use this with a computerizer? It depends. Probably you heard that before. Depending on other molecules that I'm using, if it's a molecule like flumoxazine that is non-ionized, then this is a sample of flumoxazine and I add 1 drop of compatibilizer under the microscope. As you can see, the crystals, even though there is a separation because obviously the drop falls, but the crystals are still keep their shape. Now, when I add a sulfentrazone molecule that affects the pH, if I add a drop of compatibilizer, this is what happens. The crystals disappear, residuality disappears, and the problem, also the additional problem, is that there is phyto on the crop about to be born because there is an overdose of sulfentrazone in molecular status. This is something that when Eugenia called me, I said, look, I am not a researcher and I don't know how herbicides behave in the soil after its application. I don't gather that data, but reading some work, what I want to give you is a hypothesis, a kickoff for future research work where everything that I am now mentioning can be seen in statistics and can verify what I'm telling you. Residuality problems are seen in my area and with control issues as well. So if we make a graph and we look at the concentration of an X herbicide, and we come up with 3 different scenarios, one that is correctly applied, atrazine in water, correctly applied, or atrazine that has been cut or applied together with a liquid glyphosate, or a third scenario that we normally apply because herbicides sometimes don't work, the same as the second scenario but increasing the doses. So if this is the ideal scenario for the application of a herbicide in a correct way, this would be the line under which it stops crops behaving as a herbicide, and this is the line where still has a carryover effect. The carryover depends on the crop, and following the rotation of that crop and the sensitivity to that active, and a second scenario of an incompatible mixture, and we see how the concentration very fast lowers because we don't have that delivery by the crystals. We have some weed coming out, but we see that in time we have a higher level of permanence. So using the Aapresid example from crops that went from corn to soy, you see with soil carryover of Aapresid. In my area, we see a lot of bicloran on corn, and the next crop is first-class soy. And the third scenario, carrying it with a higher level of doses, where I solve the first problem, which is the weed control, but then I have a higher residuality or carryover in time. I repeat, this is a hypothesis. We need to study it. So how can we solve these problems? One way is to replace the glyphosate formulation, always talking about concentrated solutions or soluble grains. There is something about the solid formulation of glyphosate, and I don't know exactly why. When you mixture it with solid glyphosate, that agglomeration of crystals does not happen. The bottleneck of this is that the solid glyphosate market is quite small compared to the liquid one. Then to use ethioxylide fatty alcohol that works, first added to the broth in a doses of 3-4 times the regular one, which prevents these cuts with these agglomerations. The doses, depending how much we need to increase it, that will depend on the type of alcohol that we have. We have a long chain or short chain. We need to try that. We need to prepare the mix, and also the size of the crystals of the formulation. In Aapresid, which are the bigger crystals, that's where the doses should be higher. Another solution, some ammonia sulfate, prevent the aggregation, aggregated to the beginning, they avoid or prevent glyphosate affecting the formulations. Only a few ones, we need to test them, but they work. The use of oils with microemulsion formulation, this works very well. It's one of the most effective ways. And in the mixture, if we have another active as a microemulsion, that can work if we can add it before the glyphosate. And then the last one, the use of compatibilizers, and I want to make clear that this is only where incompatibility happens due to the pH, and it happens in soluble concentrations. And as a general recommendation, there is not a recipe. You need to try everything out. There are differences with different lots depending on the brand, and everything is not as linear. We need to test, and you need to mix. So how we start, which are the brands, etc. So that's it for me.
Bueno, gracias.
Thank you very much. It was very interesting. Now it's time for questions. The QR is on screen. I was looking at my phone, and perhaps people are shy and they don't dare to make questions, but I saw quite a lot. I'm going to read one for you, Fermin. So, let's cut to the chase. What can you tell us about pre-emergent herbicides with compatibilizers? Is it good? Can we do away with its residuality? Well, I answered that when we were comparing sulfentrazone against Aapresid, the use of compatibilizers, we have to do if the molecule that we're using as a pre-emergent is ionized or not. If it's ionized, we shouldn't use it, because otherwise we're going to affect the residuality and we will have a phyto at the beginning. Then we need to really gather more information concerning other herbicides. To add a little bit more to that, there are some formulations for compatibilizers with buffers, so it's not as aggressive and residuals can be kept. Yes, that is one way, which formulation, which compatibilizer product we are using, and with which volume of the total amount we are trying it. Because perhaps we can have a test with 50%, the whole machine, it works well, and then when you take that to the field, the operator many times does it with a minimum volume, and well, the results are not the same. It's not very linear and it's not very easy. Well, actually we have many questions. How do you see the use of pre-emergents with microemulsions? Well, we need to try what type of microemulsion, but generally they work very well if they are accompanied by a herbicide such as glyphosate or paraquat, especially if they are potassic ones, and it's a solution to apply two actives at the same time. This question probably you already answered your opinion on the use of compatibilizers, but as a preventive measure. Well, the use, can you repeat it please, the use of compatibilizers as a preventive measure? As long as we are speaking about a liquid soluble solutions. There's one that I thought about actually. I think this is a nice question. A scenario using pH correctors. You spoke about correction of water in terms of pH. If it's what happens with the hardness of water? What happens with buffers? We can solve this if we have a compatibilizer and we can use cations, and one does not invalidate the other one. But what you were saying before with the corrector, there we will have a problem. But you can correct it. We need to see if these are pH correctors. And we need to assess the situation, whether these are sequestrants or not. If it's focusing only on hardness, and it can be in sync with the pH, but not directly. So we can correct hardness without affecting pH. I'm not sure. If it has a low pH, when the pH is low for atrazine, how can we manage this with the glypho and 2,4-D mix? Well, in the case of atrazine, it's not pH what affects it. But atrazine, because it's a solid, suspended, it's a dispersible grain, but when we put it in water, it's still a solid that is suspended in the broth. What affects it is a molecule that has an opposite charge. The liquid glyphosate, because of the surfactant that it's formed with, a negative charge with a positive charge, they are going to attract, and there you have a few options. In the typical case of 2,4-D glyphosate and atrazine is to replace the glyphosate. That has something that I'm not sure, I'm not a chemist, but there is something in the formulation that it does not move. Another option is to have a 2,4-D microemulsion. This microemulsion will ensure us, I don't know if you said that before, Mariano, different from the traditional emulsions. It's very small and the size, thanks to the big amount of emulsion that is a very good quality, and has surfactants, and it has the two charges in the same molecule, and that prevents the future unions. So to use a microemulsion or an microemulsion oil, those would be the options. Or any ammonia sulfate. I have been using one, I tried one that works well, and the relationship normally for Balcarce conditions where I come from and with the water that I tried it is out of 1 kilo of atrazine, 1 kilo of ammonia sulfate in the tank. There is also a line, speaking about microemulsions, any microemulsion can work to favor the molecule to be charged, and it doesn't form big crystals, yes. In the case of soy, if I use for diglyphosate and I add a compatibilizer, what kind of problem can I have? Can I expect? Well, that is a complicated mix. You shouldn't do that. It's a pre-merchant good. Glypho, Salcoline, glypho mixed could be another one, but it's not a pre-merchant herbicide. I didn't show it, but Salcoline, which is a soluble liquid, if you prepare it in water, you will see it white, but it's not this white is not non-soluble, the molecule, but because of its formulation and its surfactants and polymers that are the ones that prevent the volatilization of the active, that gives that whitish color. But if you add to a Salcoline a glyphosate, whether it's solid or liquid, that is not Panzer, you will always see crystals, more or less depending on the pH of the water, but you will see it. And if you incorporate sulfatazone, this is a ionized molecule. If you put that, you break the residuality of the other one. Phytochloroprene in first-class soy applied in corn for crystal formation. Yes, overdoses, could be an overdoses applied with glypho and atrazine. Yeah, could be the case. What can also happen, what I've seen in treatments with glypho, atrazine, and cordon, because it is believed or thought that atrazine affects the rest of the herbicides, you increase the doses of glypho. There was a rule at a certain moment, if you are going to use glypho with atrazine, you need to increase the doses in a 10% of glyphosate, and you increase the one of tordon. And picloran has a pKa. It's difficult to see the picloran crystals with liquid glyphosate. It can happen if we use a pH corrector at the beginning. But it can also happen to see in which order we charge. Because if we say, okay, we are going to charge the dust first, then the soluble liquids later. So what is the soluble liquid that we charge first, the picloran or the glyphosate? And they behave differently if we do first one or the other, or vice versa. So the order of the load also if that mixture we add also a compatibilizer, can we avoid this problem? Yeah. In this mixture we can, because atrazine is a weak basis. So that atrazine is affected, we need to get to a pH of 13, 14. From the point of view of the tank, it would be impossible. We can never go higher than 7. To add something else to that question about glypho and tordon and atrazine, normally they go together with oils, and if the oils are of well quality and separated in phases, the hormonals have a high tendency to go with the oils, and what can happen is that we have phyto of tordon, but due to a bad distribution, because that's when the oil comes to the surface, but that is effect of the hormones going to the oily phase. This one, it says we have in a scale, hardness. What is more important to correct, pH or hardness? No, hardness, because glyphosate will be in charge of correcting the pH. From Rizo, what we say is that we probably know what is the pH that we initiate a load, but it is difficult to know with which pH we are going to end up, because it depends on the brands, the size, the volume. We were speaking about this with Mariano, with tests, with another herbicide that is not a residual herbicide that is widely used for mesafen in the liquid soluble formulation, depending on the brand of the glypho that you use. There are some brands that need a big amount of compatibilizer to keep the two in the solution, or sometimes it's more convenient to have two stages, and it's quite costly. Then other questions speaking about picoloran as a problem, if we can delve into that, but I think we have spoken about that. What I see in my area is you see a lot of phyto of picoloran in corn lots that comes from potato. It's difficult to control, so we use 2 applications of thrash with 220 square centimeters of thrash. For the following year, the phyto in leaf is quite noticeable. Phytovisual. If we diminish the yield, I don't know. We need to study that. Do you have any adverse effects with pivot glyphosate? Pivot is one of the herbicides, liquid soluble herbicides, ionized, and it has multiple pKa, and they are prepared to coexist with glyphosate. It can also coexist very well. About picoloran, the question, they are saying that in Córdoba they have problems when they have a control with marihuacho. Is it better to use glypho alone? Because sometimes with picoloran and glypho they encounter problems. Yeah, probably, but I repeat, it depends on the magnitude of the damage, depending on how it was loaded. If the operator, because he was not aware of it, puts first the glyphosate and then picoloran, those lots, those batches, the phyto will be noticeable. And something that also has an impact is you prepare the first tank, the second tank is fine, the third tank it got cut off. And you cannot find any explanation, which is the remaining of what we are using. We are remaining of 100 to 200 liters, and glyphosate with a very small doses changes. So when the products start entering this broth of 200, 300 liters, when the load is reinitiated, the pH, and if we add the pH corrector, we are in a pH of 2, and if we don't have with a buffer that prevents the pH from going lower, so when those molecules enter affected by the pH, they explode. Another conventional application, we have many problems of compatibility. If the recommendation would be to apply it with a compatibilizer, we know that we have many issues, many problems. For Fomesafen, with a compatibilizer, can we make it available? We know it has to do with the pH. It is the problem, and it was the first time when we start to see the incompatibility. If Fomesafen is soluble liquid, so it's going to be in its molecular status. Due to the type of formulation, if we lower the optimum pH of operation, then it's going to be cut off. How? That is easy to see. You put it in a bottle, plastic bottle, and when you add the glyphosate, it becomes a whitish suspension of formulation instead of a translucent liquid as a solution should be. So that already explains that Fomesafen is the one that got cut off, and you will see that the crystals are big. Those crystals will go to the soil for a long time. If it's a dry year, or we don't have a big amount of rains, that will lead to phyto. We have a control in our area is resistant to glyphosate, resistant to 2,4-D, and we have these treatments, and I have experience with producers. I had one part with Fomesafen application because he didn't want to use compatibilizers, and then another one that it was incompatibilized. It looks like there is no difference. 20 days you have an outbreak of cruciferous. And the other way is to use Fomesafen that is in microemulsion. Microemulsion, the active is around a drop of oil, is not in contact with the water, with the media, so that way it doesn't get cut off.
Creo que ahí estaban todas las preguntas, o mayoritariamente todas las preguntas.
So those are all the questions. I think we were able to answer most of them. There is a concept we need to take home. There is not a recipe that fits all. We were discussing this with Fermin. It depends on the brands. But the way to add the products to the tank, that is another variable that we need to take into consideration. And let's not use the compatibilizers as the solution for everything, as we did in the past with the glyphosate, that ended up becoming a problem. So let's not just try these general solutions or general recipes for everything.
Gracias. Gracias, Fermin. Gracias, Damián.